Hello everyone, and welcome. I'm excited to have you here today. Today we're diving into Understanding Jetpack Compose, a deep dive. This presentation will explore the key concepts and functionalities of Jetpack Compose, Google's modern toolkit for building native Android UI. We'll cover what makes Compose so powerful and how it can simplify your app development process. So, let's get started and discover what Jetpack Compose has to offer. Let's talk about what recomposition actually is in Compose. Essentially, Compose will rerun or re-execute composable functions whenever the input data changes. This process ensures that the UI stays in sync with the current state or data. Now, when does this re-execution happen? Well, whenever a state or a parameter that a composable reads is updated, Compose automatically schedules that composable, along with any of its child composables, to recompose. It's a reactive process that keeps your UI dynamic and up to date. For example, if you change a mutable state, Compose will re-execute the relevant composable functions to reflect that new data. The key point here is that only the parts of the UI affected by the change will recompose, which makes the process efficient and responsive. This whole mechanism is fundamental to how Compose manages UI updates smoothly and efficiently, ensuring that your app responds perfectly to user interactions and data changes. Now, let's look at how we can integrate Compose with XML layouts using Compose View. The idea here is to add a special view called Compose View directly into your existing XML layout. You do this by including the tag andrakes, Compose, UI, Platform, Compose View, and giving it an ID, like at +id Compose View. You also set its width and height to match parent so it fills the space. Once you've added the Compose View to your layout, in your activity or fragment, you simply find that view and call set content on it. Inside set content, you can put your composables, which means you can start using Compose right there. For apps that only have a single activity, a common pattern is to extend component activity. Then, in the onCreate method, you call setContent directly. This approach makes it really straightforward to build your screens with Compose and also allows for a gradual transition. You can mix Compose with existing views, which is great for incremental updates or hybrid screens. Overall, this method provides a flexible way to integrate Compose into your app without needing to rewrite everything at once. It's all about making the migration smoother and more manageable. Let's dive into the triggers for recomposition. First, any change to an observable state will automatically trigger a recomposition of the composables that are reading that state. This means that whenever the state updates, the UI will be refreshed accordingly. Second, updating a mutable state, like using mutable state of, or collecting a new value from sources like stateflow or live data, also causes recomposition. Essentially, whenever these states change, the system knows to re-render the affected parts of the UI. Lastly, passing new parameters to a composable can also trigger its recomposition. This is particularly useful for dynamic UIs where inputs or data can change over time. These triggers are fundamental because they help us keep the UI in sync with data changes without manually managing updates. Understanding these points helps us build more reactive and efficient interfaces that respond seamlessly to user interactions and data updates. Let's talk about stateless versus stateful composables. A stateful composable is one that manages its own internal state, often using the remember function to keep track of data across recompositions. This means it's responsible for its own state, making it more self-contained. On the other hand, a stateless composable doesn't handle its own state. Instead, it relies on external parameters to receive any necessary data, which is achieved through a technique called state hoisting. A simple way to think about it is, a stateless composable doesn't hold any state internally. It's more like a pure function that just renders based on the input it gets. This approach makes your components more flexible and easier to test. By exposing both stateless and stateful versions of a composable, you give the caller the option to control the state as needed, whether they want the composable to manage itself or to be controlled externally. This flexibility is key in building scalable, maintainable UIs. Connecting this to the overall theme, understanding when and how to use each type helps you create more predictable and robust interfaces. Let's talk about unidirectional data flow, which is a key pattern in modern UI development. First, we have state flowing down through our composables. This means that composables receive data as state, and this data is passed down through parameters. It creates a clear, predictable path for data to move through the UI. On the other hand, user interactions and other events flow up via callbacks. So, when a user clicks a button or interacts with the UI, those events are communicated upwards. This separation keeps our components decoupled, which makes the UI easier to understand, reason about, and test. This pattern, especially through techniques like state hoisting, exemplifies how we can write more maintainable and testable code. It's all about establishing a clear, consistent flow of data and events, which ultimately leads to more predictable and manageable UI logic. LaunchedEffect in Compose is a really useful tool when you need to run side effects that are tied to the lifecycle of a composable. Think of it as a way to launch, suspend functions or coroutines that only run while the composable is active. The purpose here is to manage side effects cleanly without cluttering your main UI code. When you use LaunchedEffect, it automatically starts a coroutine when the composable comes into the composition. And if the keys you specify change, say, a certain state or parameter, it cancels the current coroutine and restarts it with the new keys. This ensures your side effects are always in sync with your UI state. So, when should you use LaunchedEffect? It's perfect for one-time actions like animations, data loading processes, or other long-running operations that need to be aware of the composable's lifecycle. For example, you might have something like this: LaunchedEffect, pulse rate. While is active, delay, pulse rate, update some animation state. This pattern is great for creating a continuous animation or a repeating task that depends on a changing parameter. Overall, LaunchedEffect helps you keep your side effects organized and lifecycle aware, which keeps your Compose code both clean and responsive. All right, let's dive into the differences between SideEffect and LaunchedEffect. First, SideEffect runs after every successful recomposition, which means it executes once the UI has been drawn and the state has been updated. This makes it particularly useful for running code that observes the current state but isn't directly related to the composition itself, like updating analytics or logging. For example, you might see something like SideEffect analytics, set user property, user type, user type. This ensures that every time your UI recomposes, your analytics are updated with the latest user type. Now, on the other hand, LaunchedEffect is a bit different. It launches a coroutine when the composable enters the composition, and it gets canceled automatically when the composable leaves. This makes it ideal for one-time operations or tasks that depend on certain key changes. Unlike SideEffect, LaunchedEffect runs only when specific keys change, which gives you more control over when your side effects happen. So, in the bigger picture, understanding when to use SideEffect versus LaunchedEffect helps you manage side effects efficiently, ensuring your app remains responsive and behaves as expected during UI updates. Now, let's talk about collecting flow or live data in Jetpack Compose. When working with Kotlin Flow, we use collect_as_state, or collect_as_state with lifecycle, to turn emissions into compose state. This way, our UI can automatically update whenever new data comes in, making the experience smooth and reactive. For example, you might see something like val UI state by view model, UI state flow, collect_as_state with lifecycle. This line is essentially converting the flow emissions into a state that Compose can observe and respond to. Switching gears to live data, a similar concept applies. We use observe_as_state to convert live data into a Compose state. This approach also helps the UI react to data changes seamlessly. The key takeaway here is that these methods, collect_as_state, collect_as_state with lifecycle, and observe_as_state, are powerful tools that enable recomposition whenever new data arrives. They're fundamental to building modern, reactive UIs that stay synchronized with your data sources. All right, let's look at how we can integrate ViewModel with our composables. Using the ViewModel. function inside a composable allows us to obtain a viewModel instance seamlessly. This means our UI can directly interact with the viewModel, fetching state and sending events easily. For example, in the code snippet, we get the viewModel and then collect its UI state as a state that the composable can observe. This setup keeps our UI reactive and lifecycle aware, which is essential for robust apps. Remember, composables expose data and events, while viewModels are responsible for holding the state and managing business logic behind the scenes. Now, moving on to simple animations. These are incredibly useful for enhancing user experience without complicating the code. For single-value animations, Jetpack Compose offers animate asterisk as state functions. In the example, we have a Boolean visible state, and we animate its corresponding alpha value. When visible changes, Compose automatically handles starting the animation and updating the UI frame by frame. You don't have to manually manage the animation steps. Compose does it all for you. It's a powerful way to add smooth, dynamic effects to your app, making interactions feel more natural and engaging.